Welcome back to Pentester Diaries, brought to you by Cobalt.io. My name is Jesse Rivera, and I'll be your host for this episode. Today, we are having a conversation surrounding the mysteries of reverse engineering and exploit development. I'm happy to be guided through this conversation by a Cobalt Core veteran, Andrea Durga, to give us more perspective in these areas. Andrea, thank you so much for joining us today.
Thank you so much for having me, guys.
Awesome. And now, before we get into all of that, Andrea, can you tell me a little bit more about yourself and your career in pen testing?
Of course. So, hello, everyone. So my name is Andreea Cristina. I have a bit over 7 years of experience in the cybersecurity area. I started off with a master's degree in IT and security, and then afterwards I got an internship in a security operations center department. And there I've worked on the blue team side of things. I worked with various tools such as intrusion detection and protection systems, antivirus, various endpoint protection tools, CM. And there I did also phishing analysis and all of that. So basically, everything that meant to protect an organization. So I was there, part of that team. And after 2.5 years there, I switched over to the pen test side of things. I got the chance to get into the attacker's mindset. Ever since then, I'm doing pen tests full time. I'm doing external and internal network assessments, web and APIs, mobile, clouds, everything.
So you're really digging into the meat of everything, the whole gamut, the whole spectrum. You've been from the bottom to the top, just getting your hands on whatever you can. That's awesome. And of course that's brought you to something that as difficult and time consuming as reverse engineering and exploit development. And from your take, what was your first contact with these different fields?
So first time I got acquainted with the assembly language actually was at university. I've had a course called Antivirus and Virus Technologies. So there the teacher explained to us all about assembly, registers, operations that can be made on them, debuggers, disassemblers, and all of that. That was my very first contact with it. Afterwards, my interest slowly built up because when I worked in the security operations center there, we often encountered various types of malware. So I was really curious. I really wanted to dive in deeper and get to the bottom of it, what's actually doing that malware? Does it connect to the internet? Is it sending information out? And also I was afterwards interested in anti-cheating stuff because at the time I worked in the gaming company.
Right.
So the company had an anti-cheating team. I wasn't part of it, but I was so curious what my colleagues were doing there, and it made me really interested.
Yeah, and that's, I think from my standpoint, as long as I've been in the security domain, I've always been curious about how different people create different types of malware and their purposes and use cases and how they're tied to different organizations and just how they operate, because it shows you into sort of the mindset of these different adversaries and the sort of meta of how vulnerable every organization is out there and to what. But that is amazing that you had that interest off the bat. I feel as though you have to be very, very invested if you're going to dig into the assembly code and understand the different registers, understand the functions like push, pop, return, and know where you're going with that. And so it seems like a good time to ask, how do you describe reverse engineering before we go into exploit development? How do you describe what you would be doing on a day-to-day basis?
Okay, so basically, reverse engineering means that, well, it's basically a process in which software is basically deconstructed to like extract information from it, and then you can like understand its functionality and behavior. So yeah, that would be pretty much the short definition of like what reverse engineering is.
Right.
Yeah.
And so, like you said earlier, you're working with like assembly code. You're working with C, and how does that sort of tie into the exploit development area then?
Okay, so basically, when you have like a program and you want to, for example, see what's doing, like perform a reverse engineering on it, or basically, if you're like taking part in a CTF challenge and you have their own executable and you have to like find the flag and all of that, so you can use tools such as IDA Pro or Guidera, for example. So you can like load the executable in there in, let's take Guidera, for example, and you can see like there are multiple windows in the program and like viewpoints. You can see the assembly code in one window, and like in the other you can see the C code that Gaira like tried to like show us exactly how he thinks it looks like. So you can like go through the functionality there of the application, like try to put piece by piece together, like maybe see a variable, perhaps it's like, for example, if you have an executable that requires a password, and if you like enter the correct password, it will like show you the flag. You can like try and look into the C code that Guidera is showing you and like see which variable, for example, could be the password and like what are the requirements for it
Right.
in order for you to get the flag. So yeah, you have the C code in the reverse engineering tools as well. You can like see it there and make changes over it in order for you to find out what you need to find out. What's your goal?
Okay, thanks for that great explanation. I was curious about like what sort of what level of coding practice do you have to be at for at least C coding to be able to do some of these things, in your own opinion? Is it more of like a intermediate, or is it something that you could like understand after like a little bit of training?
I think intermediate is fine. I really think it depends on how much time you are willing to invest into everything, into learning, and also practice. Practice is very, very important because sometimes you're like going through a course, it might have, I don't know, 10, 20 hours. You think that you've understood everything after you closed it down, but if you do not practice for a few months, you're going to forget. So it's always best to like keep yourself in shape. Also, if you don't understand anything, it's not a problem. Just Google it, because if you practice hard, you will learn. Or, for example, also CTF challenges are like a really great way of learning. You can like look into other people's write-ups, see how they did it, what their thought process was, and that's how you learn as well.
Right. And it's so important to have those two different languages, the assembly language understood and the C language, because you see on one hand like how calls are being made, but also exactly how the operations are getting closer to like the machine layer. And that is really daunting for a lot of people when it comes to like jumping into this field. But what's really daunting is looking at IDA Pro, like when you're looking at the recursive view of everything, and you like look over somebody's shoulder, and that's kind of like, I guess I've seen people say like that's how you can keep your job, is you see somebody in IDA and it's just like, yeah, that person needs to stay there. I don't want to do that. It's kind of that barrier. But speaking of debuggers and disassemblers, which ones do you find yourself using most often? And I know IDA Pro is like the industry standard, but tell me about your use cases with it.
Okay, so I've been using Immunity Debugger and OliDBG, and I'm also using Guidera and also a little bit of IDA. Let's talk about like reverse engineering and product development, like how I've been combining them into my pentest activities. So first time when I did like an exploit was during OSCE when OSCP. And in OSCE, I advanced more. But
Yeah.
during OSCP, I did like an exploit for buffer overflow vulnerability there. Basically, I used the immunity debugger there and also Ali. So it was a bit scary at first, like you said earlier, because you just open the program and you see all those windows and you don't understand anything like the registers and what they're doing.
Yeah.
But the OSCP course is like really explanatory, and you can like learn everything there. Like for example, for the buffer overflow, how you're sending the input, the malformed input, how you're loading your vulnerable program in immunity debugger, and like watch it crash, see what happens in the register, see that the EIP register is being overwritten with your input. And and then you're like trying to find this jump ESP address where you're gonna place your shellcode in there. I know this like a really high level explanation of like how buffer overflow works, but
yeah, and the codes in the ESP, that's where push, pop, and return, those commands lie, right?
So, for example, like for the buffer overflow in the EIP instruction, you want to have like a jump ESP instruction. So you're going to have to look for an address, or like this one. You have to like be really careful that you don't have any, that your operating system does not have any protection such as DEP or SLR there. You have to watch out for the bad characters as well when crafting your exploit in there. So yeah, once you identify at which point the application crashes, like how you have to like craft your malformed input, you have to like choose the jump ESP address that you're going to add into the EIP register, which is like the extender instruction pointer. So this one's basically saying, hey, jump to that address and execute what's like in there. So we're just basically going to say, hey, jump to my exploit and run it. So the variable application is just going to do that. And that exploit, that shellcode, actually, the shellcode is reverse shell, or also can be bind. It depends on what we're choosing. So yeah, that one should give us privileges to the computer. It depends on the fact that like if our application, our vulnerable one, is running, for example, with admin privileges, then we're having admin privileges on the system as well. But if not, then we don't. So we're going to have to like do privilege escalation from there and all of that.
Right. And that's sort of the power of all of this, right? The reverse engineering, as far as like pen testing goes, I don't think, how often would you say you'd see reverse engineering in pen testing when it comes to like most, I'd say, like I see a lot of web, I see a lot of network. I know that reverse engineering does exist in it, but how often do you actually use reverse engineering in your, testing?
So when I have to do a pen test, I don't usually have like a reverse engineering component to it. If there's like an external network assessment and I've got there like a service that's running, maybe it's something new for me, I can like try and craft a few exploits and like see what's happening there. If I get the chance to have the vulnerable software on my computer, I can just like run the service there and do some tests locally on like my machine, so that I make sure that I'm not breaking the client's environment there. So if I got a piece of software, then yeah, I can also perform reverse engineering over it, like maybe see if I get to the bottom of it, if it's vulnerable or not. If not, then if the client wants to provide us the source code, then we can also look at that and basically perform a white box assessment.
Okay, perfect. And thank you for answering that question for me. And is that sort of as far as we go with disassemblers on debuggers? Was there anything you wanted to add into that, or because I was thinking that I know that this is kind of like the perfect place to be able to like find your research and be able to automate it. And I know that some places allow you to do that. I know that IDA has like IDA Python for automation as far as like going through particular steps you've already gone through before, because it is a very in-depth process. So do you have a way in your own time that you automate things to make this a bit easier for yourself?
Okay, so basically I'm always working with like Kali for exploit development. Like I'm using Python to write the scripts for that one. I've been using, like I said, already DBG and Immunity debuggers that basically they allow us to like view and change the running state of a program. Whereas the disassemblers, they are transforming the machine code into a human readable representation, like it's called assembly language. So yeah, for scripting, mainly Python I've been using in OSCP and in OSCE as well. And during assessments, I'm once again using Python. It's the tool I'm most familiar with. It really depends on the type of the assessment that we have and the how many hours are we supposed to invest into that one, like how big is the scope.
Right.
Because if we have very little time and the scope is large, then I mean, I can automate some tasks to just make it easier, but usually there are tools that are already like made for this. So very rarely I find myself writing something custom in Python that's not already out there.
Right. Okay. And that's a good heads up. But it just keeps drawing me back to this. It's like there's so many different involved pieces to be able to do this one particular off brand of security. And I think that that's why it's a skill that you don't see as often, but is extremely valuable. That's three languages right there that you have to know if you want to. Not necessarily, you don't necessarily need Python, but like it helps in the regards of like saving yourself some time. So with all of that information, what sort of learning materials have you come across that are helpful with, you know, assembly, with learning reversing, and just in general, or even like crafting exploits, like getting ideas to do that or how it could be possible?
So I've been using like the Corellian cybersecurity research. Fuzzy Security also has some great tutorials. Malware Unicorn has this reverse engineering 101 course. And for ARM exploitation, I really recommend the Andrea labs. Like they are so good. As for the certification, basically OSCP will teach you how to exploit like this buffer overflow vulnerability that I've talked about earlier. Then I've used OSCE to learn more about the exploit development. I know that they retired the cracking the perimeter course last year, but they've introduced this advanced exploit development and antivirus evasion ones. So I really recommend this one. I didn't take it yet, but it's on my to-do list.
Okay.
I also recommend like playing various CTF challenges, like the ones from Crack Means, that one, or like CTF time, Ferron CTF, or like real world CTF. And you can also train like for exploitation with like Hack the Box or VulnHub. There are also like a lot of machines there that you can like hack, like with lots of services running. So it's perfect for trying out your exploits there.
Right. And what better way to do it than actually jumping into like a live environment and interacting with it and seeing how that performs. I think the two that I've seen on YouTube that I've kind of enjoyed, if it comes to like more of like a beginner intermediate, I know that like Live Overflow has a good like playlist on how to do it. And if you want to learn about like malware reversing, then there's OA Labs. Two very passionate, fun channels if you want to check those out. And I'm going to definitely be looking into the majority of what you've shared with me today, because I'm thinking about really pushing into that, sphere of reversing, because it is extremely in-depth and interesting. I know that IoT needs a lot of reverse engineers right now. And again, I'm trying to think. Is there like something in particular about like exploit development that people should know? Because I mean, it's hard to differentiate between the two since we've been talking about it. Reverse engineering, exploit development, they're one and the same thing. But like, is there a centralized like idea that makes exploit development different than reversing? Like I know that's kind of a vague question. I apologize, but like in your mind, how are they different?
Okay, so first of all, they are different, but they go hand in hand. Exploit development, like we can like talk about crafting our exploits, but the thing is that you do need reverse engineering so that you can get an eye into what you are doing exactly. So if you have, for example, this vulnerable application that you are trying to exploit, so we're like doing exploit development for it, you have to, for example, attach it to like immunity debugger there, and while it's running, you can try, for example, your exploit v1.0 and you're just gonna build up on that one. So for example, you can try to add your malformed input. Let's say you're adding like a lot of characters of A, let's say 100 A's, and you are sending them to the program, and you are going to see if, like, what's the behavior. Will it crash? Will it not crash? And let's say that it crashes because if you suspect that the program is vulnerable, then it obviously crashed to you before. So you're like going to try to wanna investigate that crash a little bit more.
Yeah.
So you are loading you are attaching the program to immunity debugger, and if it will crash to your input, you're going to just look at the registers there. So here we have the reverse engineering component that it is helping you as part of exploit. If you're trying to do like craft your own exploit, doing exploit development for the task. Yeah, so there you're just gonna look at the register, see what's changing in there, what's happening, and then you're just gonna slowly adjust your exploit, like see exactly where in your input is the value that will get stored in EIP, in the EIP register. And for that one, you have various tools in the Metasploit framework. There are, for example, like pattern create. I know that one's a Ruby script, so you can like use it. It will generate a random string of characters, and then it will show you exactly which ones get stored in EIP. And then you can just go back to your script and just place your jump ESP address that you have found. But that one, it's a little bit tricky to be found. You have to use, for example, Mona. That's a really great tool for finding an address. It has to meet certain requirements to work. Like I said, no protections, no depth, no SLR. So yeah, basically I mean, it's really difficult to do exploit development without reverse engineering because you need to have eyes on the program, what's happening inside, so that you can know how to exploit it, because otherwise you're just blind to that. So you just have to like be really careful.
Yeah, of course. And you're right, completely right. I see what you're saying, because it's essentially leading you to the issue at hand. You have to know when the machine is making the mistake, essentially, and then that's when you find that pain point, and that's when you start, operating as a threat actor. So I also, just for everybody out there, want to know if there's anything that you find handy as far as okay, I'm gonna actually just skip that question. I'm just wondering what sort of words of wisdom would you give to pen testers out there who are jumping into exploit development? Does it help with their career? Is it something that is just like a curiosity, or is it just something that will push them way further into different forms of research or different identities of security?
Okay, so you are completely right with what you said. So reverse engineering is like definitely like an extension of penetration testing, well, it's actually something a bit different. Like you don't really need to be a pen tester to do reverse engineering. You can simply just do reverse engineering as part of your day-to-day job. Yeah, I really recommend learning at least the basics of reverse engineering as well when you are a pen tester, because it really helps you find out more about how a program works, about its underlying components, functions, and all of that. So it's really great. So for like anyone considering this career path, first of all, I would recommend starting with the basics, such as getting yourself familiar with the assembly language. Then you can go through some online tutorials and courses, like the one that we've mentioned earlier.
Right.
Yeah, so basically any reverse engineering 101 courses and tutorials are helpful. So afterwards, when like feel ready, you can jump into some CTFs.
Perfect. Okay, so we have the early adoption of assembly, and then we jump into, you know, the courses that you might be able to find, and then just putting your hands on the testing itself. It's perfect. Yes. And I mean, it like, if I'm being honest with everybody out there, it seems like you can just like look at something and just study it, not when there's so many different parts that interact with each other. Like that's kind of like the whole issue that I had found with reverse engineering in the beginning, is just like, it's like, well, conceptually, when you normally learn something, it's under one tree of things, but this is 3 different things that you're learning at the same time. And that's not to be daunting, but it's really interesting in how they all interact with one another. So to sort of just like close up today, is there a particular exploit that you like to use or create? That is my last question for you.
Okay, so I really like exploiting buffer overflows. I guess I'm not sure exactly why I'm a fan of this, because maybe it was the first thing that I actually learned in OSCP, so I'm most familiar with this one. So yeah, it's very interesting when you find, for example, a program that crashes, when you like want to investigate that one further and see exactly what's happening. It really depends, because there are various programs, and unfortunately for us, I guess for an attacker, or for a pen tester that's like trying to find as many bugs as possible to report. They are very different to be exploited, but no other program is like the same. So you have to find your way and work hard for each of them to like see how you can exploit those.
Yeah. So it's funny, because the last thing that you want normally in your day-to-day environment is to see an application crash. But as soon as you see an application crash as a pen tester, you're just like, yes, did it. All right. Well, again, thank you so much for sitting with us today and giving us your time and walking us through all this. I appreciate all of your insights.
Thank you so much, guys, for having me. It is really an honor to be part of this podcast series. And yeah, I'm looking forward for the next podcast sessions with the rest of my colleagues.
Of course. And I'd hope to start throwing more people into the mix and joining us. I will give everybody a link to your socials so that they can find your work. And I hope everybody out there keeps hacking out. Take care.
Take care. Bye-bye.
Bye.
Hi there. Thanks for listening to Pentester Diaries, a podcast brought to you by Cobalt.io. We hope you enjoyed and welcome you to subscribe, share, or leave a review wherever you tune in from. You can catch more episodes by following Cobalt on LinkedIn and Twitter. Stay tuned for more episodes.